Okay, so this is our last section of chapter 5. Last section of chapter 5. We're dealing with friction today. Um, and if you think about the definition of friction, and we sometimes we use that in our everyday language. If there's friction between two people or something like that, and that kind of goes along with the definition that we use in physics, that the force that opposes motion is called the force of friction. So when we say two people have friction between them, it means they're kind of opposites, they're going in opposite directions, and that causes some problems. But in the physics realm, that's what it is. It's the force that opposes the motion of one surface over another surface. So if we were to look at these two surfaces on a microscopic scale, they look very smooth when you just look at them normally. But if you look at them on a microscopic scale, you can see that they are a bit jagged. And so if one is supposed to be moving across the other, then they're going to get hung up on these little jagged pieces. And that's going to be your opposition to motion. So when you slide one surface over another, they become resistant because of these little jagged microscopic hills and valleys that bump into each other and get hung up on each other. All right. So friction have both positive and negative aspects of it. So there's pros and cons to friction. Ooh, yeah, I was hoping that wouldn't happen. Um, Friction reduces the efficiency of a machine. So your car engine, if the friction gets too high in that, then your engine can just lock up and be ruined, which is why we have to be careful about making sure we put oil in the engine to keep that friction at a minimum and to keep everything running very smoothly and efficiently. But in other situations, like you sitting in a chair or walking down the street, you would not be able to do those things if you didn't have friction. Okay. So, pros and cons. We couldn't run or walk without it. So, it's important for us there. It's a positive thing there. But if we're talking about our engine or any other machine, it becomes a negative thing because it reduces the efficiency of that. All right, there are two types of friction that we're going to deal with: static friction and kinetic friction. Kinetic friction is the friction that we encounter when two surfaces slide past each other. So remember, kinetic energy is the energy of motion. So when we talk about kinetic friction, we're talking about surfaces sliding past each other. And the magnitude of kinetic friction depends on the normal force. Remember, we said that normal force is the force perpendicular to the surface. So kinetic friction depends on that normal force or is related to that normal force. So here's some diagrams showing that below. So as the figure below indicates, the force of kinetic friction is proportional to the normal force. Ooh, there we go. Let's try that again. It's proportional to the normal force. So if we double the normal force, we double the force of kinetic friction. Okay, so if we look at this, remember force due to weight and normal force are equal to each other, but going in opposite directions. Our kinetic force of kinetic friction is going to go in the opposite direction because remember, force of friction is the friction that opposes motion. So if I want to pull it in this direction, my force of friction is going to act in the other direction. And if we double this weight or this normal force, then we're going to have to pull twice as hard to get it to move, and our friction is twice the magnitude as well. Okay. So here is our equation for kinetic friction, force of kinetic friction. Force of kinetic friction. Frictions are always listed as a lowercase f. Capital F are your other forces, but force of friction is always listed as a lowercase f. We put the K in there because it's kinetic friction. It is proportional to the normal force, so that's our N. You might also see this written as F N, that's normal force as well. So it's proportional to that normal force. The proportionality constant is this thing called the coefficient of kinetic friction. Okay. So think about it in this term, different surfaces have different coefficients of kinetic friction, making them either easier to move and have less friction or harder to move. So if we compared moving something across a piece of ice compared to moving it across a piece of sandpaper, the sandpaper is going to have a different coefficient of kinetic friction. It's going to either make it easier, that coefficient of kinetic friction will either make it easier to move it or harder to move it, depending on the type of surface it is. So here's some examples of coefficients of kinetic friction. Um, the larger the coefficient of friction, the greater the force of friction. So if we go back to that sandpaper and ice thing I was talking about, sandpaper would have a larger coefficient of kinetic friction than ice would. So here's, well, they don't have sandpaper on there. Never mind. So you can see the different mu k's for interacting surfaces. Kinetic friction is if they're moving past each other. The static friction is one we'll talk about next, and that's just if they're just sitting still and not moving. All right, so table also contains values for coefficient of static friction. We'll talk about it later. Moving on. Experiments have shown that kinetic friction between two sliding surfaces is, number one, proportional to the normal force. The same regardless of the speed of the surfaces, and it's the same regardless of the area of contact between the surfaces. So it doesn't matter how fast you move those surfaces past each other. Coefficient of the kinetic friction will be the same. It also does not matter whether it's laying down flat and taking up a lot of area or whether you've stood it up on its side and it's not taking up as much area. Either one, you're going to have the same amount of kinetic friction. All right, so now let's talk about static friction. Static friction is the force that opposes the sliding of one non-moving surface past each other. So kinetic would be two surfaces moving past each other. Static is one thing's moving, but the other is not. Okay. It's due to those microscopic irregularities again, and there's going to be a figure that will show what we're talking about. So here we go. So when let's do this. Force of static friction can have a magnitude of 0. So if our speed is 0, if we're not applying any other force to it, then the force of static friction is just going to be 0. If we apply a force to it, as we're doing here, then the force of static friction is going to be equal and opposite the force that it's being pulled with, so F1 in this case. So it can be greater than 0, it can be equal in magnitude to the force exerted on it, but opposite of charge. It can be up to the maximum value of that, but the opposite one, the opposite sign. Once sliding begins, however, the friction is kinetic, and the magnitude is less than the maximum value of static friction. So all of these are before the object actually moves. Okay, so that's why we can say V is 0, V is 0, V is 0. In all three of those situations, the object, the block, is not moving. Okay, so it'll start off as 0. It can go up to the maximum value would be equal to the force applied right before it starts moving. And it would be opposite in direction from that force. But once it moves, then you don't have static friction anymore. You have kinetic friction. And that kinetic friction is always going to have a magnitude of less than whatever the maximum static friction value is, because it's once you get something moving, it's a lot easier to keep it moving than to get it moving in the first place. So Kinetic friction is always going to be less than your maximum static friction. All right, so same equation because it's dependent on the same things. The stationary object begins to move when the applied force equals the maximum force of static friction. Once the object is moving, kinetic friction is what plays a role, and the maximum force that static friction can exert is given in this equation. Again, it's equal to the same thing as kinetic friction, just a different coefficient. So the maximum static friction is equal to the coefficient of static friction times, again, that normal force or that force perpendicular to the surface. Most of the time, mu sub s, or the coefficient of static friction, is greater than mu k, which means the force of static friction is greater than the force of kinetic friction. And this is important for us. We need to know these things. Friction plays a really important role in making sure that we drive safely. When the car's moving, its tires are rolling freely, and there's a friction between the tires and the road. Um, that's static friction because as that tire is rolling at each particular instant, it's momentarily stopped and is experiencing static friction because the tires are rolling, they're not sliding. Okay, they're rolling. So at each moment as it's rolling around there, you're going to have the friction of the road and the friction of the tire because they're rolling, not sliding. So even though they're moving forward at any instant, the bottom of the tire is at rest with respect to the ground. So it for just a brief little instant, it's just sitting on that ground. And because it's just sitting there for that minuscule time period, that is static friction, not kinetic friction. So the wheels in older cars are often locked or will lock during panic braking. So in an older car, if you slam on the brakes, the wheels just lock. And that's a bad thing because when the wheels lock, causes the bottom of the tire to slide across the surface of the road. So that sliding then means that kinetic friction's taken over, which results in a reduction in the frictional force between the tires and the road. So it's kind of a good thing. So they lock up so that you don't have, so that you have kinetic friction instead of static friction. But that also means you're going to slide around a lot more because that kinetic friction is much lower than static friction. So the tires aren't going to be held onto that road like they would normally. So we've come up with what's called anti-lock brakes, anti-lock braking system. And this just uses an electronic rotation sensor to detect the wheel when it's about to skid. And then the computer pumps the brakes instead of slams on the brakes. And that pumping of the brake allows the wheel to continue moving and the car to come to a nice, calm rest using static friction instead of kinetic friction. So, in a much older car that doesn't have anti-lock brakes, if you're panicked and you think, "Oh gosh, I've got to stop," and you slam on those brakes really hard, then the tire stops, and instead of gripping the road, it starts to slide because your wheels are locked; they're not continuing to rotate. And so you'll come to a stop, but the problem is you're going to skid all over the place. And kinetic friction is what's going to bring you to a stop. Instead, if you have an anti-lock brake system, the computer pumps the brake. So you might slam on the brake, but the computer takes over and starts pumping that brake. And that allows that wheel to keep rotating. And so the car is still gripping that road, but it's doing it slower and slower. And so static friction takes over instead of kinetic friction, which is a stronger force of friction and is going to bring you to a stop more safely, if that's the right grammar. I don't know. Okay, so anyway, here is the diagram of what we're talking about. Um, so braking starts here. The analog, yeah, and you wind up skidding. So here's your analog brakes, and you wind up stopping at 37 meters. But here you're going to skid another 9 or 10 meters before you actually stop. Okay. And that's it for applying or for friction. All right, so if you have any questions about these, make sure you bring them to class. We'll be working on our practice problems with kinetic friction and static friction in class. So make sure you're paying attention and you are knowing what equations we're going to be using. Okay. All right. If you have any questions, let me know and hope you have a great day.